I'm sent to the cell. Going to I'm sent to the cell. I want to present data visualization about the foot image using ParaView, the foot image. So my image is in VTK using ParaView. I'm going to present an image of the foot using ParaView for medical analysis, medical imagination. So the problem is the foot is very important in walking, standing, running. So, but many things, how it works, are still not fully understood. So, studying the foot carefully, how it looks, how it moves, and how it holds weight can help doctors, shoemakers, patients, by learning more about the foot. So, doctors can make better treatments, better research, diagnosis, and offer good treatment by analyzing the internal structures, design of the shoe. The shoemakers can help people move, can design shoes and help people move easily and safely. So the main objectives is to analyze, to utilize the visualization probabilities and interpret medical data, which involves custom transfer functions. So we're going to study the structure of the foot, which will be used in diagnosis and treatment and planning. We are going to shade and improve the visual clarity depending on the perception of the 3D. And then we are going to visualize the internal structures of the foot, and that we see the bone, the tissue, the bone, the bone tissues, and then the skin. So when I load my image, this is my image. When I load it from the desktop into my ParaView, this is how it looks. So I'll set it representation in volume form using the volume rendering properties. So when I come to the color editor, reduce on the color, reduce on the color enhancement, I'll try to get the bone, the internal structure, how the bones look like, the color concentrations, the thickness of the bones, of each bone probably. So I can determine, so with here I can determine the nature of the bone. I can see the nature of the bone, the nature of the bone, the size of the bone probably when I remove the scale. So when I increase on the color intensity, so I can get the skin of the bone, the skin of when I try to play with the colors, I can get the skin of the bone, the color, the nature of the foot, the nature of the foot, and then I can apply ISO surfaces. So with here, I can go internally and study the bone, the nature of the bone, the nature, and then the fat concentration. So I can determine different. I can so in case the bone in I can see the fat concentration around the bone. I can see the fat concentration around the bone. So with different colors down here, I can see the color concentrations on the bone using ISO surfaces. So in other words, I can determine the cancerous cells. So I can apply contours still. I can see. So when I so when I move the bone upwards, I can see the size of the bone, the size, each size, the size of the bone. So when I apply different values, ISO values, So the first value was 2047, and then the second one was 2. So they brought clear view of how the foot will look like, and then the color concentrations. So I can study the size of the tissue. So I can determine, so with this I can determine the calcium content of each and every bone. I can apply the threshold, and then I can determine the opacity of the study of the leg. So here I'm determining the pressure when a person is moving, so I can study where pressure is more exerted. Okay, so when a person is moving, so at the bottom usually, so I can study the density, where pressure is more concentrated, where the pressure is more concentrated. So from the visualization, so we have applied the shadings of the foot using the volume rendering property. So we can determine the density of the foot using the color transfer function. So we can identify the nature of the bone, the type of the bone, and then we can detect cancerous cells in the foot using isosurfaces together with contours. So we can determine where pressure is highly concentrated in a human being using the property called a threshold, and then we have we have a simplified clarity of the internal structure of the bone using contours. Now let me try to go through paraview. And try to go some send to the soul. Going to present visualization about the foot using paraview. So my foot is in image 4, foot VKT. So problem is the human foot is very important for standing, walking, and running, but many things about how it works are still not understood. Studying the foot carefully, how it looks, how it moves, and how it holds weight can help doctors, shoemakers, and patients by learning more about the foot. So the doctors can make better treatments by studying the diagonal by through better diagnosis and offer good treatment by analyzing the internal structures. So for the shoemakers, they can design better shoes which can help them move easily and safely. So the main objectives, we are going to utilize visualization probabilities to analyze and interpret medical data, which involves custom function. Study the structure of the foot, which will be used in diagnosis, treatment, and planning. Then we are going to shade and improve the visual clarity, first deepening the perception of 3D, and then we are going to study the internal structures with the bone tissues and the skin. The structure of the foot, this is how it looks. So we shall study when I upload it. When I upload my image, this is how it will look. When I apply volume, When I apply volume rendering properties, this is how it will look. And then when I apply custom color editing using the map editor, and I try to reduce on the color concentration, so I will see the bones. So when I increase on the color densities, I'll try to see the skin. I'll be able to see the skin. And then when I apply contours and then I apply iso surface values. So the first one I used 800 and then 70. So this was it. So I can detect the size, the cells, which are the bones. So I can determine cancerous cells. So with contour 2, so I raised the values. So here I was trying to see the size, and then the size, usually the size, and get to see the protein concentration together with the protein concentration on the bone, the calcium concentration on the bone. So here I can see, I can determine, so usually the fats will concentrate on the big bone, so many fats, and then on the second bone, so there'll be little fats, and then so the size of the bone. So the larger the bone, the large fat concentration. Supply threshold. So when I want to determine the density where more pressure is concentrated when a person is walking, so try to know bottom wise. So there is high pressure which is exerted. So from our visualization, so by understanding the foot using the volume rendering properties, we can determine the density of the foot using the color custom function. We can identify the nature of the bones, detect cancerous cells in the foot using isosurfaces, and then we can determine the where pressure is more concentrated using the property called threshold. And then you can have a simplified clarity of the internal structure of the bone using contours. Now, let me go to ParaView. So with ParaView, so I'll get my image here, then load it. Oh, let me first delete this. So apply it. When I apply, change the image file, then the volume surface. So this is my image. This is my image. So I'm going to come to color editor, then try to give it a skin. So with here I can be able to see the skin. Can be able to see these are the veins, the tissues, the bone tissues. I can be able to see the toes, and then I can apply contours and can apply I'm going to try to give ISO values. So I'm going to give, so my value is going to be 800, 800, and then I give it the next one. I want to, then the second one, I want to give it 1,500, then 150, sorry, 150, and then I apply. So I'll try to see the color function. So the color function, so I'll try to see, so I can try to see fat content in the bone. Then another contour. I'll give it 220 is 40. Then the second one I give it 200. So I'll apply. So I'll see the nature of the bone. So I'll be able to apply also filters, threshold, or threshold. So when I apply it, so I'll see the concentration, the bone, and then I'll determine, I can be able to determine pressure, where more pressure is more concentrated, and then I can use it to study. So this is my presentation. Thank you for sharing. Thank you for your audience.